right, this mini lecture is just going to go over some vocabulary, a little bit of reminding. Maybe you've seen a lot of this stuff before. The idea of atomic mass, molecular mass, and Avogadro's number. So just a quick little review of some stuff that you might have had in a different class or previously in your schooling. So we describe matter, of course, in a lot of different ways, but we're going to use this idea of atomic mass. We're going to talk about that a little bit. The atomic mass is, of course, that the appreciation that each element, each atom, is going to have some level of mass, right? So some level of mass. And we've kind of normalized it as we talk about it into this standard mass unit. So one of that standard mass units are equal to 1.6605 times 10 to the minus 27 kilograms, right? So atoms are really, really, really small. They have very, very, very little mass, and this is a really tiny number to deal with. So we kind of just going to normalize it. And the atomic masses on our periodic table, for example, carbon has the atomic mass of 12.00 U, so that base unit. Hydrogen has the atomic mass of 1.0079. Yep, 79 U. So what does that mean? That means that one atom of carbon has the mass of 12 times 1.6605 times 10 to the minus 27 kilograms. Again, super, super tiny number. And so we talk about carbon just having a mass of 12 U. Okay, one atom of carbon has a mass of 12 times U. All right, pretty straightforward. We're going to talk about atomic mass in another way as well, but let's just keep moving forward here for just a moment. Now, molecular mass, that's when if we have a molecule, we're bringing two elements together, right? So molecular mass is simply the algebraic sum of the elements. Okay, so simply the algebraic sum of the elements. So for example, if I wanted to know what is the mass, so we'll use both these ideas together. Our question is going to be, what is the mass of one molecule of table salt? All right, well, table salt is sodium chloride. Okay, so one sodium atom, one chloride atom makes up a molecule of table salt, right? So what's its mass? How much mass is there? Well, sodium, if we look up sodium on the periodic table, we find that sodium has an atomic mass of 22.91 U. And we find that chlorine has an atomic mass of 35.45 U. So a sodium chloride molecule, we just are going to add these two, these two up, equals 22.91 U plus 35.45 U, and that gives us 58.36 U is the atomic mass of sodium chloride. But how much mass in our standard unit of kilograms is that? Well, we know if we have 58.36 U, and we know in 1 U there is 1.6605 times 10 to the minus 27 kilograms. Then the atomic mass in kilograms is 9.69 times 10 to the minus 26 kilograms. So one molecule of sodium chloride has a mass of 9.69 times 10 to the minus 26 kilograms. Pretty straightforward, getting an idea of how we use some of this language. So really, really small masses we're dealing with, really, really small masses. And we're dealing with, when we talk about a solid of carbon, or if I have my table salt, like 1 granule of table salt is more than a single molecule of sodium chloride, we're talking about lots and lots and lots and lots of molecules of sodium chloride. Or in a small cube of copper, I have lots and lots and lots of copper atoms. So tiny, tiny masses, really, really big numbers, right? And so we're going to use another normalization for describing these numbers. And I'm going to guess you have also heard of this. This is what we call a mole. A mole, a number, a mole is a way that we describe a number of objects. And in this case, it's usually things that we have a lot of numbers of. So a number of elements, a number of atoms, a number of compounds, okay, molecules, sorry, ions. One mole of an object, so 1 mole is equal to 6.02 times 10 to the 23rd items in that object of that thing. Okay? So 1 mole of sodium chloride molecules is 6.02 times 10 to the 23rd molecules of sodium chloride. 1 mole of carbon is 6.02 times 10 to the 23rd atoms of carbon. Okay? So it's just a way to describe a really, really big number, this specific really, really big number. And this specific really, really big number, this number here, is what we refer to as Avogadro's number. And it's not specific to atoms or ions or molecules. A mole of cats is going to be 6.02 times 10 to the 23rd cats. It's just a relationship to describe a very big number in a much more manageable way, okay? So, if we put this all together, we actually can use both the standard unit that we just talked about, 1.6605 times 10 to the minus 27, the atomic mass in its relationship, and the atomic mass relationship for moles. And so I want to introduce that one to you using an example. All right, so it turns out that the atomic mass is not only a description of the mass of a single element, so a mass of a single atom of carbon. It is also a description of the mass of a mole of carbon. So, for example, we said the atomic mass of carbon was 12 times U. So 12 times 1.6605 e to the minus 27 kilograms. A single mass of carbon, if I take a single atom of carbon, 12 times 1.6605 times 10 to the minus 27th, I get a single atom of carbon is 1.992 times 10 to the minus 26. Whoops. I'll look at my notes. To the minus 26 kilograms. Another way that this works, that this atomic mass gives us information, is that 12 grams of carbon are in 1 mole. So this atomic mass also tells us the number of grams of that element per mole of that element, right? So let's just confirm indeed that works. If this is the number of the mass of a single atom, so we have 1.992 times 10 to the minus 26 kilograms is the mass of a single atom, and I take the number of atoms in a mole is 6.02 times 10 to the 23rd, I get 12. Well, I actually get 0.012 kilograms per mole, which is 12 grams per mole. So our atomic mass verifies our atomic mass. It can be described in either of those two ways, okay? So the mass multiplier of a single atom or the grams per 1 mole of that element, right? So both can be used to describe atomic mass. Okay. Let's do this example in terms of moles, okay? So let's determine what the mass of 1 molecule of sodium chloride is, but using information that allows us to look at the moles. So using the same process, but looking at the atomic mass as the number of grams per mole. All right. So we know that the atomic mass of a sodium chloride molecule is 58.36 U, or 58.36 grams per mole. So we're going to use this lower relationship to solve for the mass of a single molecule of sodium chloride. So we have 58.36 grams per mole, and I know in 1 mole there are 6.02 times 10 to the 23rd molecules. And so if I do that math, I get 9.69 times 10 to the minus 23 grams per molecule. Okay, so the number is the same, but my power of 10 is different. But what do we notice? This is in kilograms. This is in grams. So to get the same unit, I would divide by 1,000. This is equal to 9.69 times 10 to the negative 26 kilograms per molecule. And we see that's the same. So we can use either process when we're trying to determine the mass of a molecule or an atom, whatever it is that we're particularly dealing with. All right, so different ways to think about atomic mass, molecular mass, and then this introduction to Avogadro's number. Good job.